So I'll be talking about the open source principle in this video. So it's like part of those solid principles that Margaret wrote on as part of the object-oriented design let's face. So to just give you the definition, the definition is that um, basically software entity should be open for expansion but closed for modification. And so what does that mean essentially? That basically uh, whenever we write classes, those classes should be open for extension because, like in future, you might need to extend more. You might need to add more capabilities or functionalities to the code, and but the trade-off or like the it should not affect your current, the current code and all. So let me give you an example using this famous example of the processor. So, for example, if you look in this case, in which you're not using the open close principle. So you will have all the code inside one class, which is called payment processor. So you'll have like all the code related to UPI and then PayPal and then credit card. So all of that code would be inside one single uh, class. So if you want to have a look at the code, I've written it here. So this violates OCP. You can see correctly I've written that functionality is a bad design, uses if else statements to see different functionalities. So here you can see that payment processor, you're using if else basically to, uh, basically handle different kind of payment methods, right? So what happens is, so basically, if, for example, if I have a new payment method, or for example, crypto, then this would modify my current class, right? And that definitely violates OCD because it says that it should be closed for modification. So the existing code should be closed for modification, but should be extensible. So it should be open to extensible solutions. So that's pretty much the um, so I'll talk about this one. So now I'll talk about how can we apply OCP here. So we can apply OCP using abstraction and polymorphism. So we can create one class for payment, which will basically have a pure virtual function. But I'm using C++, so that's why I'm going to use C++ terms here. So pure virtual function, I'm using that. So all of these functions can be, then later implemented by each of these different classes for each implementation. So essentially what we're going to do is, um, so payment processor was the class. We'll have another class called payment, which will then, get basically the pay function will be overwritten by all of these other child classes. So basically we're using inheritance here and abstraction and polymorphism. So three different kind of um, object-oriented design principles we're using here. So if you want to have a look at the code, so basically you can see I'm using a virtual void pay here, and then I'm using a virtual destructor. This is a very important so so that all of these classes get destroyed correctly, all the resources get reallocated. And then after that, I'm creating separate classes for each payment, credit card payment, public. So basically, it inherits the payment class and then it overrides the pay. And then this is just we are obviously not going to give you the actually implementation. So we just write this here some statements here to show that. So paying through credit card and then for UPI payment doing the same thing, paying through UPI and then for PayPal, paying through PayPal. So we've created three different kind of classes for each implementation, right? And then we have our own payment processor that you can see here, this one, which would then take the payment method, which is um, so so payment method would be of payment type, so which is our main base class here, and we will use this to simply uh, pay the amount. right? So basically we're using all these different classes here. So that's pretty much it. Then we can use this, we can create objects, stack objects here, and then simply, if I want to do a credit card payment, I would simply pass the credit card pointer, and then, give the amount. Then same similarly for I can do that for UPI payment, PayPal payment. So yeah, this is how we can use open force principle to, extend our older code. For example, now if I want to add uh, for example, now if I want to add like Bitcoin or crypto, right? Crypto payment. So I can simply do that by just, similar to this, I can just hide, just copy paste it, and I can just make changes here just to show you, right? So this is now a new payment method that I've created. So I did not change the older code. I added my own code. So I added a new class, and you can just essentially say I didn't change older code. I just added now new code. So it's extensible. I don't know what I can older code. And then after that, I can just create here crypto, um, what's the name? Crypto payment. See, then simply do the same here. Gonna pass the pointer here and give it to another value. So that's how the client code is going to look like. So essentially, we can add any more logic we want to work on. This is also used in strategy pattern, if I'm not wrong. So yeah, that's a design pattern that uses this. I think uses OCP. So yeah, that's it. Thanks so much.